Hey guys, my name is Michael Reed, and this is going to be a short video on motivation as to why you may want to start using Git or GitHub, or why you may want to start using sort of better practices in the way that you implement Git and your GitHub in your software projects. Now, one clarification I do want to make up front is that GitHub is the most common Git service hosting provider, so a website that allows you to store your Git information online, but there are plenty of other options that are totally valid as well. I will be using GitHub in this example, and so the website interface may be slightly different for some of the other providers like GitLab or Bitbucket and various other ones, but they are totally valid as well. There's nothing very specific to GitHub you need to use, it's just currently the most common provider. So let's get straight into an example. What I'm going to do is provide a little bit of background to it. I'm going to open some code and provide an actual sort of example bad situation you may get into if you weren't using Git or GitHub. And then I'll go back and I'll set up things in better software practices and then show you how things may have come out differently if you had done so. So in this particular example, I'm going to be working on making a model in Python. And in this case, maybe it's just plotting the voltage from a desalination system. This is just very much an example, and it's going to be very simple. But let's pretend for the sake of extrapolation that it's actually much more complicated and that I spent a lot more time creating it and editing it. This example is true if I'm the only developer contributing to the project, but it's also even more relevant if you have multiple contributors or developers working on the project, because as you have more people looking at the code, it becomes much more complicated in trying to edit things together at the same time, as well as trying to understand changes that someone else has made. So in this example, let's say that my coworker Jeff is working on a practical project. So maybe it's a PCB design that uses the results of my model. Maybe he's building in a desalination project using the results of the model as it is right now. Now, you both think that at the moment he has all of the information that he needs for that project that's output from the model. But of course, we find out that Jeff can't actually do what he needs to do with the results that we have, maybe because there was a minor error in the output that we need to fix before we run it again. But I, in the meantime, for several weeks, have been making changes to the code to add new features, and these don't yet work. So what I'm going to do is give you a few examples of options that you have to solve this predicament and demonstrate how front-loading some effort can save you a lot of work in these types of situations in the future. So now we're going to look at this very simple example that we're going to pretend like is actually much more complicated. So you can see that what I've done is I've imported matplotlib and numpy, and then I'm using numpy to generate a damped cosine wave, some points on a damped cosine wave, and then I'm using matplotlib to plot it. So if I just run this script here, you don't really need to worry about the details of what I'm doing here. It's just an example model. You can see that I've made this plot. And maybe from this plot, I've given it to Jeff, and that allows him to know, the damping time that allows him to generate the PCB design that he's working on. So let's say that after that happens, I then go through and I start making some changes to this model. So maybe in this case, you can see over on the right-hand side instead, maybe I decide to set up a new style. Maybe I decide to break a whole bunch of things out into functions. I've also put like the main section inside this if name equals main. You don't really need to understand the details on it. The point is that I've made a lot of changes. And in this example, let's pretend like it's a lot more changes that I've made. Maybe this is a really complicated thing that I've spent 2 weeks developing these changes for. So in this example, let's say that I did still make a mistake though. And in the example, maybe it's a much more difficult to find mistake than this particular one. Maybe it's something that would take days of debugging and then weeks of actual work to fix. But the point is that when I try and run this new version, it doesn't work. So we come up with some kind of error. So the issue is that Jeff comes back now and he says, hey, there was some issue with the original plot that you gave me, which means that I can't make this design now. So he needs to use this code project at the same time that you're developing it. But in your developing of these new features, you have a problem. That means that you can't run the code. So if this is the only version that you have, the example.py, you don't have any way of going back to the initial version of the code that did work, so that you can maybe make that very minor change. And maybe that very minor change is just that, as an example, it may just be that we want to have the plot look slightly differently, where it's using crosses instead of circles. Again, this is a very toned down example, but there may be some bigger change that you need to fix. And so the problem is that if we've already gone through and changed our code to this version, what we could do is we could save in different files each different version of this every time we make a new thing and name it like version 1, version 1.1.1 or whatever. But then there are other problems where, for example, if you make this change and it is actually a more complicated change than just having this one O to an X, how do you propagate that change into the new version of the code where you're making all of these newfangled features so that after you do fix the bug, all of the things that you fixed in the previous version also apply to the new version? This is actually a slightly complicated problem, and I'm sure you've run into something similar where maybe you've been writing a paper or something like that, and you find that the new version that you're writing has so many problems, and you kind of want to just give up on it and go back to an original version. And that's why things like Google Docs will have things where they track changes, and you can go back to a previous example of where you might be. But if we don't have anything like that set up, once we're here, we're kind of screwed. We have to just go back and manually change things the way they were before, or we have to only move forward and fix that problem that may take us days or weeks that Jeff might not have to fix. And this is the sort of like one of the most fundamental issues that you'll come into when you want to be using Git, is if you want to be developing code but also using code at the same time. Because when you're developing code, there'll be things that don't work yet. There'll be things that you don't want to maybe deploy to your website that's running this software. But at the same time, you may still want to fix things in the original code, and then those fixes you want to incorporate into your new version as well. So this is kind of the example of a situation that you may get into that's non-ideal if you're not using Git. So now what we're going to do is we're going to go through the same example, but we are going to implement Git in increasingly more depth to see what options that would provide us in an example like this. So now we're going to start looking into how to actually set up Git inside this folder in this project. So what we're going to do is we're going to set up Git so that we can do things like track the changes when we want to add new features like we were doing here, when we want to fix bugs like we were doing with the X to O, the O to X, and then swapping between those two different sort of states, whether that's two things we're developing at the same time or if it's like going back into the past. So in this case, going from this back to this. All of those things we can do in Git after we've set it up and we have started developing using Git. So the easiest way to do that, especially if you don't have any background in the command line, is to go to Google and just look for download GitHub Desktop. So in this case, you're going to have a link up the top there, which is pretty obvious, which is going to have a download for Windows, Mac OS, and then if you're on Linux, you will need to go to this GitHub repo, which you can download the app images from. And I'll provide this link in the description of this video as well. So after you downloaded it, all it is a graphical user interface. So you can see that it is a regular program like you would use in any other. You may have seen in the past that some people will use a command line, so something looks a little bit like this, and they manually type in commands. That's something you don't need to do anymore with Git if you don't want to, because some clever people have set up this application to allow you to do that. So in this case, what we're going to do is we're going to add an existing repository from your local drive. The only reason that we're not going to create a new repository on your local drive is because we already have some files that we've added into the folder that we want to track with Git. And so this one would create a new folder. This one is how you add an existing folder. So what I'm going to do is I'm then going to navigate to the folder that I want to track, which is in this case this one for me, which contains those same files that we were editing here before. And I'm going to select it. So you can see that it comes up saying this directory does not appear to be a Git repository. Would you like to create a repository here instead? And that's because we haven't set up Git yet. And previously what this is saying is if you have an existing Git set up and you want to add it to the desktop system, you can do that here. But it can also create the repository for you. So it's already generated the name automatically from our, pardon me, the name of the directory, which is all Git is. It's just a tracking system for one directory on your local file system. But we're also going to add in a description, which is going to be an example repo. Oops. That generates a plot. You can see the local path has already been selected for us. Now this next section is initialize this repository with a README. So a README, all it is a single file, a text file that just has text written inside of it. The only thing that's a little bit weird about this file is that it doesn't have an extension like some other files you might be used to, like .doc for a Word document or .txt for just a general text document. README doesn't have an extension. But other than that, it's just a text file. And what it does is it usually contains something like instructions for how to set up the repository, how to set up your code, your project, how to use it, maybe how to generate some outputs, and maybe even like some motivation as to why it's useful or something like that. So if I go back to this repository, which is the GitHub Desktop itself, which is in its own Git repository, funnily enough, this is their README. So you can see that when you open it on GitHub, the first thing that you see is obviously all of the files that are inside it, but then also the README, because the first thing that you see is maybe it has some information like what is this repository used for, how to install it, and all kinds of other interesting and useful information like that. So those are the kinds of things that do go into the README. If you initialize it with an automatically generated README, it will just have a file that just contains the name and the description inside a file. So you can also very easily manually make it or just edit from the one that is automatically generated as well. In this case, I'm not going to select that because I already have a README saved inside, but selecting this is usually what you want to do, especially if you're starting something from scratch. Now the next thing is the git ignore file. So what a git ignore file does is it chooses which files inside that directory that you're tracking to not track. Now it's a little bit of a complicated reason as to why you might not want to track some files, but the lucky thing is you don't actually need to worry about it. So I'm going to have a very brief explanation as to some examples why, but don't stress if you don't understand what this means. So as an example, in this particular project that I'm using as an example, I have a virtual environment. Now that virtual environment contains a whole bunch of installed libraries that I've installed just for use for this project, and that is something that's automatically generated and takes up some file space size. It also may be particular to the system that I'm using, maybe because I'm using a Linux system or Windows or Mac OS. The way that this gets generated may be slightly different. So if I track this in Git, then when someone else downloads it, it'll have this file, which A, is taking up some extra file space inside the GitHub web repository, and B, it may not be generated in the right way that someone needs to use on their different machine. So it's better to not track this inside the Git. Luckily, you don't really need to worry about this too much, because what this step is doing is it's letting you pick a default version for a particular type of project. So in this case, we're going to select Python because I'm making a Python project. And it's going to automatically generate that .gitignore file for me so that I don't need to worry about it. There will be some cases where you may want to add certain files or like certain things to that .gitignore file, but in general, you don't need to worry about it at all. Last thing here is the license. So the license is something that you save with your code that essentially determines how other people can or cannot use your code. I'm not going to go into too much detail here, but it is important to say that this is something you should consider fairly early on in your project. Because if you don't provide a license, or if you provide the wrong kind of license for what you want to do, that may prevent other people that you want to work on your project to be able to work on it, or it may also allow other people that you don't want to be able to change your project to change your project. So something to consider and not just entirely disregard when you're setting up a project. In this case, this is something that I'm showing online. I don't really care at all. So I can, for example, just select the MIT license, which is a fairly open license, which allows this to be an open source project. So I'm now going to click Create Repository. So you can see that it just flashed up a quick screen there, which was actually committing all of the first changes to my repository. So what that just means is it was saving the state of my code as it is right now. So we have this new interface. There's a bunch of confusing things that we're going to get to in the future, but what this suffice to say, we have now created our Git repository, which means that things are now being tracked, but we will need to do a few steps to make sure that's being tracked with best practices. And the easiest way for us to check that that's the case is if I go back to my directory where I have all of my files and my project, you can see that there's a new folder here called .git. So what a Git repository actually does on your local system, it doesn't store anything else other than things inside this .git directory. And what that is it's a bunch of files that you're never really going to manually go in and open, again, unless you're doing something very advanced, that tracks the changes between how to go from different versions of your code. So as an example, if we started making changes from this and to this, the .git directory would just save those different changes and allow this desktop application for us to change between those different versions. So as an example, if at any stage you decided that you wanted to delete your Git repository, all you need to do is delete this file, this folder, here. So if I delete it right now, you can see that in the GitHub Desktop it says cannot find it, because all of that information that Git is storing is all inside that one directory. So now the GitHub Desktop has no idea what's there. To it seems like the Git repository has entirely disappeared. So that's just like a quick explanation that it's not sort of like a scary set of files where you can't touch your files anymore because you may mess up the Git system or whatever. Everything is contained within that .git directory. So obviously you won't actually be deleting that in practice in almost any case, but it's not a complicated, scary process. It's just adding these files inside that directory that tracks how things change. So I've just set up the Git repository again after I deleted it just before, and you can see that we have that same interface up previously. So some quick important things is up in this top left, you can swap between different repositories that you may be using at the moment. So right now we only have the one, which is this demo that we're using. But if you have multiple other projects you're tracking with Git at the same time, you can select them in this list here. This section here then also has the list of changes as well as the history. Now you can see that in our history, we only have the one thing at the moment, and everything here is green, because what it's saying is the only change that we made in this initial commit is that we added all of the text in each single one of these files. Because previously, nothing existed, and then we added everything there. So what a commit is, you can think of it as just like a state. So whenever you make a commit to your Git repository, all you're doing is you're saving the code as it is at one particular time. So that if you ever want to come back to the code as it looks at that state, you can check out that commit. And all that really means is the system will automatically use that little .git directory, pull the information out as to what the code looked like at that time, and then change your files to look like that. So it's not really like a complicated thing. They just use a different word to essentially mean something like state. Now what changes indicates is the current changes that we have from the previous state that we had. So at the moment, the previous saved state was initial commit. But if I go in and I change something, so for example, I go in and I'm going to maybe start changing my init file to look more like this final version. So at the start, let's just make something very minor as a change. Oh, actually my linter is automatically removing that, so I have to add this in as well. So I've made this very small change. If I go back to the GitHub Desktop application, you can see that it's tracked specifically the changes that I've made. So that's useful because internally, Git doesn't actually save a different version of your files every time. It doesn't take a copy and then save all those files in one place. All it actually saves is the changes between them. That's useful mainly internally for Git because it doesn't take as much space. But in the future that we'll see, as you do things much more complicated, if you're only saving the changes, it makes it very easy to, for example, if I fixed something here, like changing this from an O to an X, that's just a change. And that's a change that I could then propagate into the new version of the code as well, if that section of the code still exists. So what it means is that if we're tracking the changes, it means that maybe someone adds this new setup style, but then someone else at the same time is adding a new feature, and in this case it would be on a different branch, which we'll cover later, this separate thing here. So one of the changes would be adding this, and one of the changes would be adding this. So then, if you then need to decide in the future, okay, we now want to combine our changes, normally what you'd have to do is manually go through, see what's changed, copy and paste things in, but Git can see that you've both made an addition to this file, for example, and it would apply those changes together to give you something that has both of them at the same time. If that's confusing, don't worry too much. This isn't actually something you'll generally need to cover. It is just a useful feature that you may want to get into in the future as you get things a little bit more complicated. The point is just that as we make changes, we see those changes reflected in the GitHub Desktop here in the different files. So if we then also, for example, made a change to something else, so I'm going to open up my README, and I've got just to do here, and I just added a new line that also says to do. And we'll also see that that separate file also appears here, and we can see the changes that we've made, where in this case we just added a line and added that to do. So now that we've made some changes to the file, how do we save that as a new state? How do we make a commit, as Git calls it? So in the GitHub Desktop, it's quite easy. We just come down here. So one thing that it does require us to do is to add a summary and a description for what this change is. So that's useful because if you ever need to, for example, come back to this state of the code, you need to be able to find which one it is, because it may be that over the course of several weeks, I will make maybe hundreds of commits, each with a tiny little change. And so to find the specific one that I want that has a state that maybe, for example, is the one that Jeff used to start making his PCB design, it's important for me to give descriptive summaries and descriptions to these. So in this case, what I'm going to say is that the change that I mainly made was to add styling. I'll get there. So I added styling to the matplotlib. And so now it's fairly obvious if you ever want to come back to this particular state after I've done some more things, maybe where I make a bunch of mistakes and mess up the code a whole bunch, it's going to be very obvious what's happening at this state of the code. So I'm going to commit that, and now you can see that it goes back to this same view that we had before, where it says no local changes, because the previous state, and you can now see in history, there's a new one, which is add styling, and it just has a list of those same changes that we were seeing in this section before. But now we haven't had any changes since we made that commit, and so that is just going to have no local changes listed here. Now the nice thing, which we can immediately start doing, is if we decided, for example, that that style is, maybe Jeff was writing a paper and he had an initial version that didn't have that styling. So we need to go back to a version before that styling was the case. I can now right click on this one, and I can say checkout commit. Now what that means is change all of the local files that we have to this version of the Git repo, to this commit, to this state. So if I go back to my files right now, you can see that I still have those changes. So I actually haven't saved this one, which is a little confusing. So give me 1 second, I'm just going to go, oh, I see. I'm going to undo that then. Save that. Okay, good. Okay, so as you can see, in my version of this file, I still have the setup style. So I have that change that I made, which is in this second state, the add styling. So if I want to go back to before I did that, I right click and I say checkout commit. So it comes up with this, which just says checking out a commit will create a detached head and you will no longer be on any branch. You sure want to check out this commit? Don't worry about what that means for now. It's something that sounds kind of scary, but it's actually a fairly simple thing. Essentially just means that previously we were linearly going between different states of changes, and now we're going back to something previously, and so it doesn't really know how to track where we're going from there, because there's one branch, which is the future of what we already changed, and so we'll need to actually make a new branch, which connects into something else. Don't stress about it too much. The point is, if I go back to here, and now I open up my file, that change is no longer there, which is very useful if I need to go back and make some changes, for example, for that particular state of where the code was at before. So now just as a quick explanation of how we get back to where we were before. So if we want to take our file and then make it still have the setup style, because of the thing that we're not going to go into too much detail now, that other version is no longer available. And that's just because we're on a different branch, because we're on a detached head. Don't worry about what that means. If you go back to the branch section up here and you click on main, or the only branch that's there, you'll see that add styling comes back. And if I then go back and open my file, you can see that that setup style is there again. So I just want to reiterate here again as well. Git itself isn't something, like the only way that it stores information is within that .git directory. And the way that it actually interacts with your code is that you save states, and then you use the GitHub Desktop application to go through and open or make changes to each of those states, so that it makes it easy to go back and forth between different versions of your code. So in this case, the actual file that's stored on my local machine, which is init.py, will change if I go between different commits of my files. So this file on my directory has actually changed, but that information is also not gone, because the change to get it back to the original state is still stored inside that .git directory, and I can go back here and open it up using that method. So it's very difficult usually to set up a Git repository, or to break a Git repository, which is something that a lot of people are often very nervous about. The general good thing about Git is that as long as you are making commits fairly regularly, so you don't do a whole bunch of stuff and then not make a commit and then delete a bunch of things, in that case, because you didn't make a saved commit or saved state in between, there's no way that Git's going to be able to help you restore to that state. But as long as you're making regular saves of that state, making commits to your repository, it's very easy for you to go back to whatever situation you want to in the future. And so it's going to be very difficult for you to mess up the Git setup inside your folder. Okay, so now what we're going to do, guys, we're going to take this repository that we've been making some minor changes to, and we're going to publish it to, in this case, github.com. So this GUI that we've actually been using is something that's actually generated by GitHub themselves, but it's just a wrapper around Git, which is the actual software itself that is making these changes and storing these different changes inside that .git repository. So using the GitHub Desktop, I don't think there is actually a way to publish to any online repository other than github.com. But in this case, we're just going to use github.com. There's absolutely nothing wrong with github.com. It is the de facto standard that most people use, so that's what we're going to do. So I guess some questions that may come up then is, why would you want to publish to github.com? And making all of these changes and tracking all of these things in the ways that we've been describing is something you can do entirely locally to your machine. So the only reason that you may want to publish to github.com is A, if you want to share the project with other people around the world. So that's a fairly obvious thing. If it's on the internet, other people can also have access to it. But also github.com allows for a lot more features that Git doesn't have locally in terms of interacting with other people. Generally like some GUI things, although a lot of those things exist on the GitHub Desktop now, that allow you to have other coworkers make comments, but also like add bug definitions on side like the GitHub website. We're going to go through those by looking at them though. So first all we're going to do is we're going to go down here and click Publish Repository. So this button's going to exist here if you haven't published, if you haven't pushed it up to github.com at all yet. But then also as you make changes in the future, we will still have to push those changes to existing up on the internet, because if we make those changes locally, they don't automatically sync to the website in the same way that something like Dropbox would. It'll make sense as we go through them though. First what we're going to do is we're going to just publish. So in this case, I've already signed in, and so I actually changed versions of GitHub Desktop during one of these videos so that I could sign in. But generally, all it's going to do is prompt you to open something on your browser. You're going to log into github.com, and it'll bring you back in here. That might happen at this stage, or it might happen when you first open GitHub Desktop, depending on what version of GitHub Desktop you have. So in this case, it prompts you again for the name of the description. This is just something that's going to go into the github.com kind of setup. You can also choose to keep this code private or not, but this is something you can also change on github.com in the future. So for now, I'm just going to select it to be private because that's kind of like the safer option in the intermediate, but I can open it up later. So as you can see right now, it's pushing everything up. So now you can see that this button, it changed from being publish repository to fetch origin. And the reason what that means is origin is just the word that GitHub will use to be like the original source for your code. Now, because you have things up on the internet, the idea is that someone else may make a change to your project and push those changes up to the website. But your laptop maybe hasn't been connected to the internet, maybe you haven't pulled anything new down. So the idea is that there may be changes at the origin, so like the place that your Git repo is determining to be like the source of truth for these things. And so fetch origin means pull down the latest information from the internet and see if there's any changes I need to make from my code that were made on the internet. Because again, it doesn't happen fully automatically like something in Dropbox would do. So in this case, if we click fetch origin, nothing's going to happen because I'm the only one that has access to the repo and I haven't pushed any changes. So what I'm going to do now though is I'm going to view it on GitHub so that I can show you what things look like on GitHub itself. It's just opened up on that other screen, so I'm just going to pop it over. So this is what popped up for me. So you can see that before we had that README screen in the other repository that we're looking at, which was, sorry, pardon me for 1 second. Yep, this one here. And so we have a very similar interface here, but in mine, because I just had that file set to to-do, that's what we see here. It also contains all of the files that we have, and it's got a bunch more features here. We're not going to go into a crazy amount of detail, but I'll very briefly go over some stuff. Issues, for example, is where someone would add in either a feature request or a bug that they've seen. Maybe this is a coworker, maybe this is yourself, maybe this is someone that's working on an open source project with you from somewhere around the world. So as a quick example, just to demonstrate, what this is, maybe it's like, we want the plot to have X's instead of O's for readability. Maybe I'll change that to I, makes more sense. Get there eventually. And then, I'd add a more detailed description, but I'm not going to do that in this case. And, you can do things like assign the person that this task should go to, give it labels, like in this case, it's an enhancement, it's not a bug. These are things I'm not going to go into too much depth. But the idea is the idea of an issue is something that exists only in GitHub. It's not something that exists in a local version of your Git. So if you deleted the GitHub version of this project, but you still had it locally in your drive, you would, for example, lose the information inside the issues section because it's a separate different thing. Then there's like pull requests, which is a way that you sort of like merge different versions of your code into this sort of like main version of your code. Actions, which are like scripts that you automatically run maybe when you push things up. So maybe it's things like running tests, maybe it's generating some documentation or whatever it is. And there's a few other things you don't really need to stress about. The point is now our code is up here. And if I, for example, open up this file, which I was looking at before, you can see that it is just as it was on my local machine. Sorry, this one here. And then the other interesting thing is that all of the information about different versions of your codes, the different commits, is also saved here. So you notice that in this case we have 2 commits. And remember, like a commit is like a saved state of your code. So if I go there, this is exactly the same information that I had stored on the GitHub desktop. If I go to history, add styling and initial commit are the 2 different types of states, and even the times the same thing. It also shows that it was me that made those changes, etc. So now that code's up there, for example, someone else could make changes to it, push those things up, and then I could pull them down into my local version so that we can collaborate on the same project at the same time. So now what I'm going to start doing is I'm going to start going through and making some changes to my code to take it from this state to this state. And as I go, what I'm going to do is every time I make a change that does a particular function, I'm going to save the state by making a commit at that point. And I'm going to show what that looks like and what it means we can do with that afterwards. So in this case, for example, I may start then adding in, I'll have the if name equals main section here and the setup style. So now you can also see, if you're interested, I have my command line set up to also give me some information about the Git repo. And when it's yellow or orange, this means that the branch that I'm on is main, and it also means that when it's orange, there are some changes that I need to commit. But if you're not interested in the command line, instead you can just open up this again, and you can see that we've got changes listed here. And when there's changes, that means that there is something that we haven't saved to a state. And so if we don't save it, then this means that it's not something we can get back to. So after we've finished doing a little bit of work and we have it in sort of a point that we may want to come back to in the future, and then going to make a new commit. And so I come down and I just write some things here. So I moved, let's just say, created init section, moved script to init section, actually executed style change. Because actually in the last version, we weren't actually executing the style change. So I hit commit to main. So now an important thing to note at this point is that I have saved that state to my local machine. So my computer now has those 3 different versions of the code. And I can open up any of these 3 different versions of the code at any time. But the GitHub website does not yet know about those changes. So if I go back here and I refresh, and now you'll see there's still only 2 commits. But then if you want to be extra sure, and I open up this file again, you can see, that these changes have not yet come up to this version, which is in github.com. And that's because I haven't pushed them up to the website. Because right now, these changes, all they are changes that are on the files on my local machine and inside that .git folder, which is stored on my local machine. So all I need to do to make sure that that goes up to the web is click this button, which is push origin. So in this case, all that means is we're pushing the data up to the original version, whereas the state of truth of all this code, which is just the github.com repository. So if I hit push, you can see it's running through that process now. And then I go back and I reload. You'll see that there's now 3 commits, one of them being that one that I just made. And if I click on this, it also shows those little changes that I've made. So great, I'm going to keep going and make a few more of these changes. So let's say that I want to have this new setup of the plot, which is just going to add some titles and things. And then I need to run that instead of the other version that I had. Now the other thing is that normally I would be trying to test all of these things before I actually make a commit to them. So this time I actually am going to test that everything is working. So I'm going to run this init.py. You can see that it is coming up. It's now showing things the way that I want it to. It's got the title, all that kind of fun stuff. So that is correct. That is what I wanted to do in this particular instance. So now that I've finished that particular feature, I'm going to come back here and I'm going to make a new commit. So I'm going to say added titles and subtitles, axes titles. Change the appearance of the plot with titles, etc. I'm going to commit, and then I'm also going to push it up to origin to make sure that it's available on github.com as well. So great. Now if I go back to history, got all that, I'm going to keep going. So now I'm going to add these 3 different types of plots to not just have the original type of plot. And then I'm going to add in this section so that they actually get generated. And then I'm going to plot them. Place this section. I'm going to run it to test it again. And again, let's say that in this example, there's actually lots more complicated things that we're doing all together. And this is what I want in this case. I'm going to go back and I'm going to make a commit. So added underdamped, overdamped, and non-damped, critically damped, whatever. added the new kinds of data to the plot. Commit to main, push to origin, and I'm going to keep going. So the very last thing that I want to do in this particular example is I'm going to also save a version of the file. So you can see this is there. I'm also then just going to open up the directory to show that it's also created a file, which is this saved file here. I'm just going to use this as an example for some stuff in the future as well. But also this all works now, and I've tested that it works, so I'm going to make one more commit. So saves an image of the plot. Saves PNG image of the voltage plot to the local directory. Cool. So an interesting thing that I'm going to go and show you in this as well is that I have added this image into the Git repository. So this means that it is also being tracked, and as I make changes to this image, those changes to the image will also be tracked, and this file will be pushed up to the GitHub repository. So that's okay in this particular instance because this file is not a particularly big file, it doesn't take up a lot of space, but maybe this file that I'm generating is actually a huge file. Maybe it's like a 3D file, maybe it's like a point cloud thing, a huge CSV, whatever it is. But the point is that this image is very easily generated by the code. It's not something that is like something that I've written. It's something that can get remade every time someone uses the code. So it's not something that needs to be saved inside the Git repository. So this is an example of a perfect thing that shouldn't be saved inside the Git repository, and so should be added to the git ignore file, but it can be added to something called a release, which I will explain in a little bit. But for now, just know that we have all of these changes that we've made, and you can see that, for example, I now have this new version of my code, and let's say that I did still have an error in it, so when I try and run it, there's a problem. But then Jeff comes over and he's like, hey, I want to go back to that original version of the code, and I want to change something really minor so that it has that change that I want to have. So I'm not going to, actually, yeah, what I'll do is I'll commit this. So added a fake error. So now if I go back to history here, I can find that specific section that I know that is this the time that I want it to be. So in this case, it may be the initial commit, and this was the point that Jeff wanted me to work from. So if I check out that commit and go back to my original file, you can see that it is exactly as it was at that point, and it plots the plot exactly as it was then. So going back and forth between that initial version that I may want to make changes to and my latest version, where currently I have some sort of issue, is very, very easy. And I didn't have to save different versions of the file that I need to go and look for in different things. And I didn't have to label them in very convoluted ways because all of my labeling is stored here inside the Git repository. And that's a very simple example of why tracking these things in Git could make it very easy. Now then, you can also do all of the same thing and view all of the same things inside the github.com version. So again, I can open up 6 commits here, and this is exactly the same interface as I saw before, and I can go through and I can see what each of these versions look like, and this allows me to work out which point I want to go back to and check out that the actual version of checking it out would happen inside the GitHub Desktop, or if you want to, within the terminal. So everything that we've done up to this point is kind of the bare minimum you can set up for a Git repository, and that is creating your project, setting up a Git repo, committing changes every time you make a new feature or fix a bug, and then pushing everything up to github.com, all working by yourself as a single developer. So the next thing that I'm going to do is I'm going to show you a couple of the more better practice things that you want to do holistically, which is kind of like the next step above doing that bare minimum setup. So to do that, I'm first going to delete the repository both locally as well as on github.com, just as to show you that it's really not a scary process as long as you're okay with throwing away some of that alternative states of your code that you want to save. So for example, in this case, if I kept my code at the most recent version, so if I go back over to my code, sorry, wrong one. If I go back over to my code, if I want to keep it the way that it is and I don't want to save any of the previous states, then it's okay to go and delete the Git repository. But if I want to, for example, if I have this one checked out, so it's in a previous state, and I want to have that new version, but I also want to delete the Git repository, then that's kind of dangerous, because as soon as I delete the Git repository, the only information that I have in that folder is the files that are there, which means that it's only the files that is in the state. You lose that whole history of things as soon as you delete the Git repository. So just make sure that if that is something you want to do, which is usually a pretty rare case, just understand that you're losing all of that previous information, which I do want to do in this particular case because it's kind of a unique situation. So the first thing that I'm going to do is I'm going to go to my Git repo. So this is where it is. And just again, this .git folder is where all of the information about my Git repository is held. So as soon as I delete that, it's now gone. Everything about the information about all the previous versions of the Git repo is gone. So similarly, if I now open up my command line, you'll see that it no longer understands that this is a Git repo. And so the only information that I have is the files as they are saved right now. If I open up Github Desktop, you'll say that it's all lost. The good thing is that if you've done it at this stage, you can actually pull that information back down from the GitHub repository, because all of the information that I've pushed up is still available there. So I could hit clone again, and it will just clone all of that information, including any of the code in the current state that it is. But in this case, I don't want to. So I'm just going to hit remove, and that's just going to make GitHub Desktop forget about this repository. So now to actually change that on github.com itself, I'm going to open up just my browser to here again. And if you go to settings, and you scroll down here, it's got a bunch of things literally called the danger zone, because it's a bunch of things essentially that you can't undo. So one thing that I want to do at the moment is delete this repository. If you want to also archive it, in a sense you want to make it non-active, but not actually delete any information, that's something else you can do. But right now, yeah, I'm going to delete it. So we're going to click, I want to delete this. It tells you that, if you do this, it'll permanently delete the stuff from the website. So again, it's not something you often want to do, but if you've really messed something up, it's pretty easy to do as well. And one thing that it might ask me to do is put in my authentication code. So bear with me 1 second, and I will come back after I've done that. So I just put in my two-factor authentication code, and now you can see that my repository is deleted. This is where it took me afterwards, with just a list of the other repos I have on this account. So I go back to the dashboard, I can click new, and I can start again from there. So what I'm going to do is I'm going to go back to my original code as it was. I'm going to first create a new repository from an existing drive, so the same thing that I did previously. To navigate back to the same place, select, create a repository, example, done. I'm not going to initialize any of these. I guess I actually already have one from the previous time I did this. I'm just going to click create repository. We're exactly where we were before. I'm going to publish it. I'm going to do the same thing, blah, blah, blah. After that's done, I can view it on GitHub again, close this one, and I'm pretty much back to where we were before. So now, the thing that I'm going to do a little bit differently this time is first, I'm going to make branches in my development scheme. And then secondly, I'm also going to set up releases. Now, I'll explain through what each of those mean as I go, but it's essentially just a slightly different management style that adds a little bit of complexity to the way that I'm tracking the changes in my files. That makes it a lot easier to do things like develop new features while still having a different section of the code that's only for deployment or for use with the hardware design that my coworker Jeff is using, or putting on the website that is currently being served to customers or something like that. So first, I want to explain a little bit of background about what a branch is. So in the previous version of when we were developing and making commits, it was a very linear set of changes that we were making. So you could only go from one to the next, and you could jump back and forth between any point in it, but all of the changes happened in a sequential mode, which is something that doesn't always necessarily make sense in development. If you're making something very simple like what I've been putting together here, of course it makes sense. But let's say that, for example, two people are working on two different new features in the code base that we're doing. Maybe one of them is changing the way that the plot looks. Maybe one of them is generating a new set of data, like one of those different curves. Now, if you're both editing the code at the same time, then it's going to get very confusing very quickly as you make changes. So let's say, for example, the first thing that I want to do is I want to add back in this setup style section. So I'm just going to add in some things to make this work. And then I'm going to run that function. So now if I run, that's what I want, this file again, you can see in this case it does work. But let's say, for example, that I made a mistake. And so let's make the same mistake that I was making previously. And I run that now, and it errors out. But let's say that at the same time, my coworker Jeff, for example, he was trying to set up this different section where we also had an undamped set of data. So maybe he's adding in this function at the same time, and he's trying to set up this to run that extra function. So maybe he's getting gen undamped data. It's x2. And maybe let's even just add in the original one as well, so it just makes a little bit more sense. And we're going to take these two. Place that whole section. And plot both of them. So if everything's going well at the same time, at the very minimum, it's going to be very confusing because Jeff, maybe let's say we're both committing to the GitHub account or the GitHub repo at the same time. And so at some stage, Jeff pulls my changes and he sees that the style has changed. So even if everything was working, he would see that things look differently in the output that he's generating without him having actually changed anything, which is super confusing. But in this case, even while Jeff is making his changes, maybe originally the system totally works because I didn't have that set up and it outputs the correct plot like you can see here, but then he makes a pull from GitHub and it adds in my setup style thing, and now his code doesn't work. But it's not because of a change that he made, it's because of a change that I'm making at the same time. Obviously that's really confusing and it's going to be a big problem. Now, this is true for if you have multiple people working on the same project, but it's also very true if you're working on individual sets of features. So like the example that I was saying before, maybe you have the idea that you want to swap over to using a different library than NumPy to generate this, but you're not really sure how it's going to work. But you still need to have the original code operational so that maybe Jeff can use it for his thing, or maybe you need to come and use it and make some changes, fix bugs or whatever. So being able to have a different version of your code that branches away from the main branch, that has a different set of features, but maybe isn't fully functional yet, and maybe you haven't decided if you want to move that back into the definitive version of your software, is very useful. So there's a lot of literature you can find online that explains this a lot better as well. So this is the Atlassian website. Atlassian is a software company that has a lot of specifically very good tutorials on Git, but it provides this sort of diagram. And this is a diagram that you'll see very regularly if you're looking into Git, because this is a branch diagram. Some people call it a tree diagram. So as you can see previously, when we were having the very sequential changes we were making, where we just went from one state, we made some changes, and so that links to a new state, and then make some changes from that and links to a new state, that is one single branch, which you can see here as main. And if I go back to my GitHub, that's the default name that Git will give to the default branch that you have inside of your code. But if at some stage you want to make a new feature, for example, something that might make sense is from that point you branch off. And maybe you continue making changes to main, or maybe someone else continues making changes to main. And then once you have finished this feature, that's when you'll merge it back into the main feature. So in this case, what that would kind of look like, at least just at the file level, is after I had fixed this error in my code, that's when I would merge it back into the main branch. And then if Jeff was doing this other work, he would still not see that change his individual code, because he's probably working on another branch himself. So I would merge back into the main branch. So I would take this little feature and I would merge it back into the main branch, but maybe Jeff is working on this green branch, so he doesn't actually see the changes until he decides to bring them in, or he decides to merge his change back into the main branch. So this is all a little confusing without an actual example. So what I'm going to do is I'm going to take this all the way back to where it was before. Oop, a little too far. And then I'm going to do these new changes, but as branches. So if I go back to GitHub Desktop, you can see that I'm back where I am with no local changes. So I'm on the main branch. I haven't done anything different. But now what I want to do is I want to change the style inside the inside this project that I'm working on. So what I'm going to do is in GitHub Desktop, I'm going to go to the branch button here. So you can see that if I did already have other branches, I could choose them to move my state, my commit, to a different branch, and I can also create a new one. So what I'm going to do is I'm going to create a new one, and I'm going to call this new style. because that's a fairly good description of just what I'm putting together here. I'm going to create the branch. So as you can see, nothing really different has changed here. The only interesting point is that this button popped up, which means that this new branch that I've created is still only local to my machine. So if someone goes onto GitHub, the website that we have, the repo up here again, they're not going to see that this exists. So you can see there's a section here, branches, and at the moment it only has main. And that's because I haven't pushed the information up, because it's similar to commits, which is states of the code. You have to push them up to the website before they understand or have any information about that. So now that I've done that, if I refresh this, you'll see that I have a new branch, which is new style. So now I go in and I make my changes. So I go back here, and I'm just going to do exactly the same thing that I did before. Bear with me 2 seconds. And so let's say, for example, that I still had that issue. So it's still not working properly. So if I run this again, I'm going to get that error. But maybe I still want to save the state of this file, because I've done a whole bunch of work and I want to be able to come back to it, but I still want to go and work on the main branch, because maybe I'm working together with Jeff on something while working on this, when we have a little bit of spare time. So I would still want to commit this, and I would still want to push this up to GitHub. So what I would say is, started adding styles, not yet working. Because it's a pretty descriptive state of saying that if someone else wants to look at this, it doesn't work. It has an error, but it's still a state that has an interesting and useful, state of the code. And so I'll just say, started adding in features to change the plot style, but there is still an unknown error. So I'm going to commit that, and that's saved it locally to that state, and I'm going to push to origin. So this actually prompts me a little bit here to do it here, but you can just click it. Either one is fine. It's the same thing. So now if I go back to GitHub, for example, I can see that new style has had recent pushes, which means that there's new information on this different branch. If I go and I open it, you'll see that if I go to the file, it'll have those changes that I've made, which is great. And then also, if I go to GitHub Desktop, it's very easy for me to now swap between this area where I'm making new changes and the main branch, which is the sort of safe, well-tested, well-defined version of the code, which is where we should begin, new branches from, for example. So if I click main from this branch thing here, then if I go back here, it's actually changed my local file to go back to the state it was at before. So similar to when I was changing commits in the single branch before, in that linear sort of definition of changes of different states of the code, what I've now done is I've made that different branch, and I can swap to different points of different commits, one being on the main branch and one being on that new branch. So let's say, for example, that I've been working on this new feature. Let's pretend like it's a much more complicated feature. We don't know what the problem is, and so we're going to put it aside for a little while we do something that is maybe a little bit more important. So what I'm going to do is I'm going to check out the branch, which is the main branch, so not the new style where I'm making these new changes. And now the code is back where it was previously. And then I'm going to start doing that other stuff, which I think is the more important different work. So I'm going to again make a new branch for this particular case, because I'm going to be making some things that I don't know exactly when they're going to be functional, so I don't want to make changes to the working state of code. So I'm going to go back to GitHub Desktop, and I'm going to create a new branch. So I'm going to say adding in different damping curves. I'm going to create branch. So now if I go back here, I'm going to start making those changes. Add in these functions. I'm going to take these lines, add them here, and then take the plots as well. So now you can see that I can run this code, and it works, and everything is entirely separate from that other work that I'm doing, which is changing the style, which currently has some sort of issue. So if I go back to GitHub Desktop, I'm going to make a new commit here now, and I'm going to call it added curves for other damping. I'm going to commit. So what we can do then is if we go back here, we have 3 branches. One is that new style, one is the main one without any changes, and one is adding in different damping curves. And if I go into, after I publish this branch, if I go into GitHub, you can also see that all of these branches are going to exist there as well. So you can see that adding in different damping curves had recent pushes. So now I have 2 different things that I'm adding in. And the next question is, how do I take those changes that I've made and bring them back in to the main known working branch of code so that other people will know that this feature is finished, it's working, it's able to be put into new versions of the project. So the term that we're going to use for pulling this change into the main branch, so moving it back in, merging it back in, is a pull request. So the reason that we're calling it a pull request is because you can directly merge these changes back into the main branch directly, but what is better practice is to create a request that goes into github.com where other people can review these changes before they go into the sort of known working state of the code. And this way you can have, for example, your manager or a coworker or something of yours check these changes that you've done, or maybe you can even just provide it as a good way for you to make sure that you're checking all of the differences that you're putting in, and it tracks the way that these things get merged in a just much better documented way. So in GitHub Desktop, we have this section that's called Preview Pull Request or Create Pull Request. Preview pull request just means it's going to bring up a preview of what it looks like first, but you can also just directly create pull request. So in this case, you can see that what I'm doing is I'm taking the branch that I was working on, which is adding in different damping curves, and either because we have created tests, or in this case, just because we've manually tested it, we know that those changes work and everything is going great. So what I want to do is merge that back in to the main branch. And so you can see here that I could change it to adding it into new style, which would be a very complicated way of merging. Generally, what you want to be doing is just making branches from your main branch and then merging them back into there. So in this case, we're taking this branch that we made and we're merging it back into main. So if I create pull request, it's going to open GitHub, because a pull request is something that only exists on GitHub. It's not something that actually exists in the Git system itself outside of GitHub. Don't really worry too much about what that means. If you're going to be using GitHub, you can kind of consider them as one and the same. But if you start doing some advanced stuff, it maybe is sometimes important to realize that they're different things. So in this case, we could say description of all of the changes that we made. In this case, we only saved one commit, only one change. So it's actually only going to be that one thing, like added curves for other damping. But maybe we did multiple different things. We made lots of different commits, and maybe we want to add a description for what they all are in this one section. So in this case, I'm not going to do it, but maybe you would summarize all of the different changes if you're doing something a little bit different. In this case, you can also create a draft pull request, and that's kind of just like a managerial thing where if you start making changes, you can make a draft pull request before you're done, and then it kind of gives you a list of all the things that you need to do before you actually merge it in. You don't really need to worry about that if that's not sort of like a managerial thing you want to do. So we're just going to create the pull request. So you can see that what GitHub is doing here, and actually even GitHub Desktop was doing this for us before as well. It gave us a thing saying that there are no conflicts with the base branch. And what that means is that because Git is just tracking the changes that we make, it is then trying to apply those changes back into the main branch. Now, in our case, the main branch hasn't had its own changes that continue on as well. But what we may have been doing is we may have gone back to the main branch and made more changes to it. Like maybe we need to fix up some stuff in this very basic version. So then you have 2 differing changes, and you need to work out if there's anything that is changed in both versions. So for example, maybe I add something new to this ax.plot section, but in the new branch that we made, I've entirely deleted that. And so what happens to those changes? That's when you would have something that's called a conflict. And it would bring it up in this interface to show you hey, this version wants to have that line look like this, but this other version entirely deleted it. So which version do you want to pick? And so you have to go through and you have to select for each of these changes that aren't able to be easily added together, which version you want to use as the new definitive version of that line of code. So you can see that if you have very simple changes you're doing, this is going to be a very easy thing to do. But if you're doing lots of big complex changes with a big merge conflicts between them, that whole process of resolving the conflicts can get a little complicated, which is why it's always nice to merge your branches back in as quickly as possible. So generally what that just means is breaking down your branches into small feature sets rather than huge feature sets that you merge back in maybe like 3 months in the future or something like that, just because it makes managing this section a lot easier. So in this case, we don't have any of that, so we're going to click Confirm Merge. And what that means is that if we go back now to the branch, which is the main branch, those changes that we had on the adding new damping branch are now applied to the main branch. So all it means is we've taken those changes and we've brought them back into that different commit. And then if I go back to my local files, if I fetch origin, and then I pull origin, so there is kind of a semantic difference between the two of those. Fetch origin is kind of just pulling data about the state of the repository. Pull origin is actually pulling down the new code. You don't really need to worry about the differences between the two of them. Sometimes you just have to press the button twice, is essentially what it does. But now you can see that I'm on the main branch, and if I go into my init file, it looks exactly the same as it did in the adding in different damping styles branches, which is great. So something that may help you visualize these changes that we just made with branching and merging and things like that is something called Git Graph. So VS Code has an extension. So if you go into the site here and go into extensions, extensions is just like plugins that you can add into VS Code that lets you do various things. So VS Code has something called Git Graph that will create a visualization like this. Now you can also find other GUI applications to do something very similar. There's a very popular one called Kraken that you pay for, but you can also generate a very similar visualization within the command line as well using a command called Git Graph. But the point is, these visualizations are very similar to the one that you saw in that Atlassian tutorial that I brought up previously. So what it shows is that this blue line is the main branch. So this is the one where it's like sort of the defined, good state of the code. Now we first branched off from that, from our initial state of the code to create that new style. And you can see that because we haven't finished it, that just ends there. So it's something that we either need to decide to bring back into the main branch, or maybe we'll abandon it, whatever it is. But you can see that it hasn't come back in yet. But then we also, from that initial commit, branched off and made an adding in different damping curves branch. And then you can see that we merged it back in, and that's what's created this new commit at this point on the main branch, which is the thing that we're showing. Actually, not right now, because I'm on a different branch. But if I, pardon me, open up the main branch again, then that is where we're at right now. So, and you can also see that it's now changed to show that that is the active commit by having that not filled in that circle anymore. So this is a great way of kind of just like visualizing exactly what's happening. So the next thing that we may want to do is take this new style, fix it up, and then merge it into the main branch as well. Something that I'm not going to cover in this is rebasing. And what that means is that if you're continually developing this new feature, but you can see that you're also making a lot of changes down your main branch, you may eventually want to take some of these new changes and incorporate them into the new style without actually merging new style back into the main branch. If that's a little confusing, don't worry. It's not something you usually have to do, but that's something called rebasing. So it is something that is usually covered in GitHub Desktop, though I think it's not yet quite supported in the Linux version, so I can't show you here. And it is also something you can do in the command line, but it's something you can very easily find a lot of tutorials for as well. So in our case, what I'm going to do is I'm just going to go in and I'm going to check out new style, which was the area that we had that was having issues before that we still hadn't fixed. I'm going to go back to my code. I'm going to fix the problem. So in this case, we actually know what the problem is, but maybe it would actually take a long time to fix. I go over, I make a new commit. So I'm going to say fixed styling error. I'm going to push that up to origin, which means that it's all up on GitHub. And now I'm going to create my pull request just like before. I'm going to see the changes that I make. That's exactly the changes that I want to do. You can actually see here that we cannot automatically merge because we have some of those merge conflicts, which is going to be a great example to show you that. So I'm going to hit create pull request. It's going to open up GitHub again. New style. I'm going to say, as a description here, we added some code to change the styling of the plot. And now if I hit create pull request, and it shows the changes I made there, it's now checking similar to what GitHub shown before, and it says there are conflicts that must be resolved. And the conflicting files is just in init.py, because that's the only one that we're changing. So great, it's got this button now, resolve conflicts, which we can click, which will help us work out what the issues are. And it brings up this new interface which I'll explain through in 1 second. So the way that this works in GitHub is that it just displays for you this section here, which is this red bar, which shows where the conflict is. And now Git itself, not GitHub, has added these extra markers as well. You can see this one indicates that this top section is what the change is from the branch new style. And this section here is what main originally had that section as looking like. And you can see that the way that Git is tracking these changes, it's saying that I can't add these two together automatically. There's going to be something where I need someone smart to come in and decide what we keep and what we get rid of. So you can see in this one, the biggest issue is probably because previously we had just this XY generating from that one function, and then we split it out once we merged in that other branch into main into this other section here. This is the new section that we actually added inside the branch, and that's what we want to keep. So in this case, GitHub kind of expects you to sort of manually choose the bits that you want to keep. In a little bit, I'll show you a different method of resolving these conflicts inside VS Code, which gives you a couple of buttons, which lets you automate if you want to pick, just one section or just the other section. But usually what you want to do is some combination of the both. So you'll need to be a little bit smart in the way that you do it. So in this case, what we're going to do is we know that we don't want this section anymore. So I'm just going to select it and I'm going to delete it. I know that I do want these two sections, but I actually want this setup style to be down below here. And then I can just delete these markers, which were originally showing where the conflict was. And now that we're done there, what we can do is we can hit markers resolved. And it says, okay, now everything's good. So I understand how you want to merge these things together. So I'm going to commit the merge. So now GitHub is going to take this version and create this new version that everything is merged together. So very similar to before, after we resolve this conflict, we can now create the merge requests and then confirm the merge. So if I go back now again to the init file, and I'm on my main branch at the moment, and you can see that it has both of these changes put together. And then if I go back to GitHub Desktop and I fetch origin and then pull origin, then I can open main and you can see that it has my changes. And then if I try and run it, it has both of my changes there together. Now, there are other ways of doing this locally, using Git on your local machine, and then VS Code has a bunch of tools to help you with doing source control, which is Git is a type of source control, where you have an interface inside your code editor where you can make those changes. I'm not going to go all over those at the moment. There's a whole bunch of different ways that you can create these merges and you can resolve these conflicts. I just wanted to give you an example of how to do that and show you that it's really not that scary. The only way that it does get a little bit complicated, like I was saying before, is if you have a huge amount of changes. And so you have that merge conflict editor open and it has like hundreds of different things you need to go through and understand which version of what you want to do. But that is also, it makes it a little bit easier if you first rebase, which was the other thing that I mentioned before. So you can test everything together in your branch before you move it into the main branch of your code as well. So there's only two more things that I want to cover before the end of this video. The first one is setting up issues and how you can use those to create new branches. So what I'm going to do is back onto GitHub, I'm going to go into issues, and because this is a new repo because I deleted the old one, I don't have any other issues. So what I'm going to do is I'm going to add a feature request. So what I'm going to say is here is automatic saving, automatic export of the plot as PNG. Now I'm going to assign this to myself. I'm going to say that it's an enhancement. And then the next thing that I'm going to do is, after I submit the issue, I'm going to create a branch for this issue or link a pull request inside this development section here. So what that's doing is it's allowing me to create a new branch according to a new feature that I've requested. So in this case, maybe it's Jeff as my coworker, maybe it's someone else has requested this new thing. They've added it onto GitHub, so it's something that we can all track to see how well we're doing it, going through and fixing all these things that we need to do in our code base. And then directly from here, I can create a branch from that issue so that I can make a new branch for that thing that I'm doing. So in this case, I'm going to name the branch, maybe just export plot as PNG. I'm going to go create branch. I am also going to say checkout locally, because that'll just bring up this. This is something you would use if you're using the command line. But what we can also just do is go back and do this in GitHub Desktop. So in GitHub Desktop, we're then going to fetch origin, which is going to pull all of the information from the GitHub website, because at the moment we made the branch, but only in github.com, not on our local machine. And then I'm going to go here and see that in other branches, we have listed export plot as PNG. And that's because it pulled down the information from that, but it's not a local branch yet. So I'm going to open up this one. And so now we're inside that new branch, which means that I can go to my code, open up my init.py, and I can add in that section that I want to add. Oops, space there, is that right? And then I would test it. And so if I test it, and then once you go and, okay, so I did open this, just open my other screen, sorry. And I'm going to go and just check my files, and it does in fact export that image as stacked voltages or stacked voltage.png. So I know that's good. So now what I want to do is make a new commit of this one. So I'm going to go over here, go to my changes. I've got these two changes, so I've got this one here. I'm not going to add it to my git ignore file because I'll get into that a little bit later. Although I think maybe you can actually have ignore file add to git ignore. Oh, okay, so I haven't seen that GitHub Desktop before. So that's very nice. And I'll explain a little bit later, while I do that. But I'm going to say added functionality for PNG export, commit export, push origin, and then the last thing that I want to do is another pull request. So I'm going to, very similarly, create a pull request. It's going to bring up this last thing. I spelled that wrong, but that's okay. Create pull request. And the only reason that I'm doing this pull request is so that I can pull it back into the main branch. So obviously it's a little bit sort of silly to do it for such a simple feature that we just did. But if you imagine this is a bit more of a complicated thing, keeping this isolated as its own branch and then merging it only back in when it's finished and complete and tested is a very, very useful thing to make sure that the code that you're sharing between other people, the code that you're using as the one that you deploy to your website or whatever it is always working, but still gives you the freedom to do lots of crazy things when you're developing new features and break everything without compromising the main branch of your code. Okay, so now that we've had that main branch, one other thing as well that I'll note here is you can delete the previous one if you want to, because now we don't really need it now that we've merged it back into the main branch. I'm going to go up, fetch origin, and then similarly, I actually didn't need to publish that branch. That's just adding it back again. I'm going to go back to main, and then just, if I open it up again, we'll see that it now has this saving feature here. So I've come sort of full circle, and you can see that here I made a new branch and then merged it back in from the Git Graph. So that's great. Now there's only one last thing that I want to cover, which is releases. And that's where we're going to be putting that image that we removed from tracking in Git just before. So hopefully it makes a little bit of sense as to why you wouldn't want to add the image to your Git tracking. And that's just because it may be a very large file, it automatically gets generated, and so it's something that doesn't need to be stored in github.com. But that still poses a problem, which is that if you have these generated files that you have, it's kind of frustrating that they're still not immediately available. Because maybe, for example, this output, this plot, is the interesting thing that we care about, and I want someone else to be able to see what that plot is at different stages and use it as a reference that they can use for other work. So what I can do to solve that problem is something called releases. And what a release is it's taking a particular state of the code, so a particular commit, and you add a name to it first, which is called a tag. And so the tag is essentially just a much easier way for people to refer back to it. It's very similar to having the commit name like we have here, but it's something that's generally a little bit more authoritative. So maybe you put version 0.1, maybe you would put version for paper in June 2024 or whatever it is, but it's something that gives it a name. But then the important part is in a release, you can also add files in a zip file that gets stored on github.com that are only related to that one particular state of the code. And so that's the place where you would put files that are generated. So for example, like this image. So I'm going to set you up with an example of doing it. So what we're going to do is we're going to right click on a particular commit. So in this case, we're going back to the initial commit on the main branch. So this was the very start of the code where we had it before. So what I'm going to do first is I'm going to check out that commit. And what I want to do is generate the image again. So if I go back up here, you can see that the code is as it was before. And if I run it, I'm going to get this file come up. And what I'm going to do is I'm going to save it. And I'm going to save it in that same directory. And I forget what I called the other one. I think it was voltage plot or something. It's not really too important. So now I've got this image saved. And so it's important because maybe this was at the stage where Jeff started doing his work. So he needs to be able to refer back to this, and it's kind of annoying for him to need to go and regenerate it himself, even though it's something that we don't want to store in the Git. So what we can do instead is we're going to go back to GitHub Desktop, and I'm actually going to go back to main just to show that we can see everything at the same time. I only went back to that one just so that I could generate that image and have it there. Although I just realized it will delete it once I do that. So I'm going to check this out again and just make sure that I have that image saved. Voltage plot. Oh, I see. I've saved it in an area that I can't access. Give me 2 seconds. I'm just going to save this in a different place. It's because I'm running this in a dev container, something you don't need to worry about. Okay, I've resolved that issue, so I've saved it locally. So now I'm going to go back to GitHub Desktop. So what I'm going to do, and I think actually I can swap back to my main branch. It's still going to stay there. There's no problem. Yeah, all good, because I'm Git ignoring it. So what I'm going to do is I'm going to create a tag. So I'm going to right-click on this commit and go create tag. So then I just need to put in a name. So for this case, let's say that I'm going to say it's Jeff's hardware version, or whatever it is. Maybe I just say it's like 2024 July release. Whatever it is, you can pick anything as long as it's something that's going to be easy for you to refer back to. So now that I have that tag made up there, and I push it to origin, I'll be able to go and see that in github.com. So similar to like issues, releases are something that only exist in the context of GitHub. So it's not something that gets saved inside your local Git repository. What we're going to do is we're going to go to tags. So from that main section of the repo, we just click this section, which is next to branches, tags. And you can see that our 2024 July release is there, and that's because we pushed after we've made it there. So if we go to releases, what I can do is I create a new release. I'm going to choose a tag. So that's why we need to have already created a tag. Although you can also manually create a new tag from one of your commits here. So I'm going to click this one. And I'm going to say, this is the state of the code when Jeff started his hardware project. Now, importantly, what we can do is attach files to this version as well, and it's going to wrap them up into a zip file and keep them there. So what I'm going to do is click here, and I'm going to go down to where I had that file saved, that image, which is generated from the code in this state, and then I'm going to publish release. So now I've got a release here, which has the state of the code because it's it's also linked to a commit, which is that commit that we had, but it also has files, assets that you can connect to it. It also makes it very easy for you to download the source code as a zip file as it was at that point. So you don't have to go through the whole Git thing of checking it out or whatever, if you want to make it very easy for someone to get the code at that specific state as well. So next thing we're going to do, just for fun, is we're going to go to the latest version as well. I'm going to make sure that's checked out. So yeah, we've got the latest version here. I'm going to run it, and that's going to generate my image again and save it. So I'm just going to open it up in my local file to make sure it's correct, and it is. And then I'm going to make a tag and then a release for that one as well. So this time, let's make the tag on GitHub. So I'm going to go back here to the tag section. I'm going to go to releases. I'm going to, draft a new release. Choose a tag, find or create a new tag, and then I'm going to say, let's say finalized. Well, that sounds wrong, a bad word to use. Let's say like 2024, and let's just say this is August. New hardware version. I'm saying this just to keep it very colloquial. Generally, what you normally put in these kinds of things is like a semantic version number. So you might say like version 0.0.2, which just makes it very easy, very sort of like clinically able to refer back to. Now what this is saying is like the target is where you're pulling it from, so which commit that you want to get it from. So if I click from main, it'll be from the latest commit in main, which is the one that we're working on right now. And again, I'll just say, this is the plot generator with multiple types of damping and a new style, whatever whatever it is that you want to say. And then again, we're going to attach that file. We're going to go and we're going to find that image, which is a new version of the image, and then publish release. You can also see that we're setting this as the latest release, which means that if anyone comes in and they'll see that it is the most recent version. So the important thing about this now with the assets is maybe you have some code that generates a whole bunch of 3D files. Maybe you have a code that compiles down to an executable file. Maybe you're generating website files that you need to upload to your website provider, whatever. All of those assets can be stored inside this, so that if at any point someone needs to refer back to a released version of the code, so usually it means sometimes that you send it out to a manufacturer, you deploy it to your website or something like that. So another example is I use Git to track all of my PCB designs, and whenever I generate the manufacturing files for a new PCB design and send them to a manufacturer, I save that as a release. So that when I get the PCB and I see some problems with it, if I need to see exactly what the manufacturing files look at that time, I can go to that release and I can check what that release file looks like at that time, which is the plot as it is there. And then if I need to go back to the original version, and maybe Jeff needs to refer back to and see what the issues were that we originally saw there, he can go back and you can see that original file as well. And this is where you generally will want to keep those generated files inside releases, not inside your source code on github.com. And so that's kind of it. That's everything that I wanted to cover. I know it was a lot that we went through, but this is a very introductory version to using Git. There are also a lot of topics as well, like setting up a good README and making sure that you have good methodologies of naming your branches and making sure that you're merging quickly enough. But those are all advanced topics that you don't really need to stress about just yet. I kind of just wanted to push across the point that using Git can allow you all these different tools to make it very easy to work across time with yourself, work across your big complexity projects where you're adding lots of different features, and most importantly, working with other people. Using Git in this kind of way makes life a lot easier. So again, if you have any questions, feel free to drop a comment. And also if you're in the Gear Center, feel free to just message me on Slack. If you have also questions about your specific project that you want me to help you out on, I'm more than happy to do that. See you guys later. Bye. So that's basically everything that I wanted to cover in this video for now. There are a lot of topics that I didn't cover, like writing a slightly better README to make sure that you have good instructions, proper etiquette and sort of how you set up your issues. There's also setting up milestones and projects, the ways that you name your branches. You can go, like I said, as deep as you want to into the best methods of using Git, but as long as you start using Git and you decide to slowly learn a little bit more over time, I hope that this video has at least demonstrated to you that opens up a number of tools to you that can help you solve problems that you wouldn't otherwise be able to solve. If you're part of the Gear Center, feel free to send me a Slack message if you have questions about a specific project. If you're watching this on YouTube, feel free to drop a comment. I can try and get back to the ones that I can. And see you guys for the next video. Bye.